Welcome to AI Frontiers, your trusted destination for exploring the most significant advances in artificial intelligence. Today's episode is titled, Vision Unveiled, The Cutting Edge of Computer Vision, with the subtitle, 16 Papers, Highlights from May 22, 2025. In this episode, we embark on a comprehensive journey through the world of computer vision, spotlighting 16 impactful research papers published on a single day. Our exploration will focus on synthesizing these influential works, revealing dominant themes, methodological innovations, and emergent future trends. This presentation is meticulously designed for researchers, practitioners, and enthusiasts alike, offering an in-depth look into how machines see and understand the world. We will examine how breakthrough research is driving the field forward, providing both context and technical clarity to ensure accessibility for listeners at all levels of expertise. Join us now as we delve into the latest frontiers of computer vision research, setting the stage for a rich and informative discussion. Let us set the stage for what to expect in today's episode. The discussion will navigate the evolution and persistent challenges within the domain of computer vision. Over the course of this exploration, 6 major research themes shaping the field will be introduced and analyzed. Listeners can anticipate a deep dive into 3 paradigm-shifting papers, each selected for their transformative impact and technical innovation. Furthermore, we will unpack the key technical advancements and their real-world implications, providing clarity on how these innovations are influencing both methodology and application. By the end of this episode, a clear trajectory for the future of machine perception will be charted, equipping the audience with a comprehensive understanding of the current landscape and emerging opportunities in computer vision. A brief overview of the field highlights computer vision's expanding horizons. Computer vision is the technology that enables machines to interpret, analyze, and generate content from visual data, including images and videos. It powers a wide array of applications, such as autonomous vehicles, advanced medical diagnostics, security systems, creative industries, and robotics. The field has evolved from reliance on handcrafted features, methods for detecting edges, textures, or geometric shapes, to the widespread adoption of deep learning, which allows for the extraction of complex patterns from vast datasets. Current research is now focused on tackling multimodal integration, explainability, and robustness. These advances are central to artificial intelligence's growing impact across both scientific inquiry and industrial deployment, reflecting the field's dynamic and influential nature. The first major theme centers on multimodal reasoning and inclusivity. There is a growing emphasis on integrating vision, language, and audio, enabling artificial intelligence systems to process and relate information from multiple sensory modalities. This trend is exemplified by the work of Gabora and colleagues, whose ARB benchmark highlights the significance of cultural and linguistic gaps in current models. The ARB benchmark evaluates models for stepwise reasoning in Arabic contexts, addressing a long-standing underrepresentation in AI research. Multimodal benchmarks such as ARB expose the limitations of state-of-the-art models, particularly when tested on tasks that demand cultural awareness and stepwise logical reasoning outside of English language contexts. As a result, inclusion and diversity are increasingly recognized as research priorities, guiding future directions in both model development and evaluation. The second theme focuses on efficiency and scalability at unprecedented levels. As models continue to grow in size and datasets become more complex, efficient processing has become essential. Techniques such as adaptive tokenization, exemplified by methods like adapt-talk, dynamically allocate computational resources, optimizing for both speed and resource consumption. The work of Brasso and colleagues introduces native segmentation within model backbones, reducing the need for separate, task-specific components. Additionally, linear attention mechanisms, as implemented in models like LA-Former, enable real-time analysis of high-resolution imagery. Content-aware architectures are driving scalable solutions, ensuring that high performance can be achieved without prohibitive computational costs. These innovations collectively address the pressing needs for efficiency and scalability in modern computer vision. The third theme addresses robustness, safety, and generalization in real-world contexts. Vision systems deployed outside controlled environments encounter dynamic and often unpredictable challenges, including variable lighting, occlusions, adversarial attacks, and domain shifts. The detection of adversarial and out-of-distribution data is critical for maintaining the integrity and reliability of these systems. The work of Wong and collaborators, specifically the bad depth paper, exposes new risks associated with backdoor attacks on depth estimation models, highlighting potential vulnerabilities in safety-critical applications. Research efforts are increasingly focused on developing models that can adapt safely and reliably to new domains, detect security threats, and maintain robust performance under a wide range of conditions. Addressing these challenges is essential for the safe deployment of computer vision technologies. The fourth theme explores generative models and the ongoing innovation of benchmarks. Diffusion models have established themselves as leading techniques for image and video synthesis, restoration, and editing. The GOT-R1 framework, presented by Duan and colleagues, leverages reinforcement learning for advanced text-to-image reasoning, enhancing the alignment between generated outputs and complex prompts. Training-free interventions, such as those exemplified by the Frank model, further boost reasoning capabilities in large multimodal models without the need for retraining. Benchmarking frameworks, including Reveal, have been developed to improve annotation quality and fairness, ensuring that evaluations are both meaningful and reproducible. Evaluation protocols are continuously evolving to address tasks that require compositional reasoning and spatial understanding, reflecting the increasing complexity of real-world applications. Key findings from these 16 papers are driving computer vision forward in significant ways. Multimodal benchmarks consistently reveal persistent gaps in model reasoning, particularly in underrepresented languages and cultural contexts. Reinforcement learning has been shown to optimize not only final outputs but also the intermediate reasoning process, as demonstrated by the work of Duan and collaborators. Segmentation capabilities are now emerging natively within model backbones, as presented by Brasso and colleagues, eliminating the need for dedicated task-specific heads. Security vulnerabilities have been identified in depth estimation models, with the bad depth paper highlighting the risks of object-level backdoor poisoning. Finally, the importance of data quality and the development of inclusive, rigorously constructed benchmarks have been underscored as critical factors for sustaining progress and ensuring equitable, reliable model evaluation. Methodological innovations underpinning today's advances are both diverse and sophisticated. Reinforcement learning has been utilized to guide reasoning and generation processes, with frameworks such as GOT-R1 optimizing for both intermediate and final outputs. Chain-of-thought prompting is increasingly employed to build transparency, encouraging models to generate and follow explicit stepwise reasoning during both training and evaluation. Content-aware tokenization methods are boosting efficiency by dynamically allocating computational resources based on input complexity. Cross-attention mechanisms are enabling the fusion of multimodal data, supporting richer and more nuanced understanding of visual, textual, and sometimes audio information. Finally, the renovation and creation of benchmarks ensure that evaluation remains fair, reproducible, and reflective of real-world challenges, supporting the scientific rigor essential for meaningful progress. The first seminal paper highlighted in this collection is ARB, a comprehensive Arabic multimodal reasoning benchmark, authored by Sarah Gabora and colleagues. This work addresses a critical gap in non-English, culturally grounded evaluation by introducing the first large-scale benchmark for stepwise reasoning in Arabic. The ARB benchmark spans 11 domains, including visual, textual, scientific, and cultural tasks. It evaluates not just the final answers provided by models, but the entire reasoning process, allowing for a nuanced assessment of coherence, faithfulness, and cultural sensitivity. Findings reveal that even top-performing models struggle with logical reasoning tasks presented in Arabic, especially those requiring cultural grounding and domain-specific knowledge. By setting new standards for inclusivity and cultural sensitivity, the ARB benchmark lays a foundation for the development of more contextually aware and equitable artificial intelligence. The second seminal paper is GOT-R1, Unleashing Reasoning Capability of Multimodal Large Language Models for Visual Generation with Reinforcement Learning, authored by Chungchi Duan and collaborators. This research introduces a dual-stage reinforcement learning framework for text-to-image generation, optimizing both intermediate reasoning steps and final outputs. The approach achieves state-of-the-art results on compositional benchmarks, particularly in tasks demanding complex reasoning and precise spatial arrangement. The model autonomously discovers sophisticated and interpretable generation strategies, surpassing traditional outcome-only supervision. Additionally, the release of community resources, including code and pre-trained models, supports benchmarking and further research, enabling broad engagement and facilitating the adoption of these innovations across the field. The third seminal work is Native Segmentation Vision Transformers by Guillaume Brasso and colleagues, which redefines segmentation as a native feature of the model backbone. The paper introduces content-aware grouping layers that enable segmentation to emerge naturally from the feature extraction process, eliminating the need for task-specific segmentation heads. This design achieves strong performance in both supervised and zero-shot settings, with hierarchical grouping layers accurately delineating object boundaries and semantic regions. The architecture simplifies model design, boosts computational efficiency, and generalizes effectively across domains. The public release of the project supports reproducibility and further innovation, establishing a new paradigm for segmentation in computer vision and paving the way for more efficient, adaptable models. Looking to the future, several challenges and opportunities are poised to shape the continued evolution of computer vision. The expansion of culturally and linguistically inclusive models and benchmarks, as demonstrated by the ARB benchmark, remains a pressing priority. The advancement of reinforcement learning and step-by-step reasoning for both generative and analytical tasks is expected to drive greater interpretability and adaptability. Efficiency remains paramount, with ongoing research into adaptive tokenization and scalable backbone architectures, as highlighted by Brasso and collaborators. Deepening multimodal integration across sensory domains promises to unlock new capabilities for generalist robots and interactive systems. Finally, the renovation of benchmarks is essential for real-world, diverse deployment, ensuring that evaluation protocols keep pace with the field's growing complexity and application breadth. A brief note on the synthesis and review process for this presentation. Content has been synthesized using the GPT-4.1 model developed by OpenAI. Google text-to-speech technology was utilized for the narration, and Grok contributed to the conceptualization of image design elements. Every synthesized segment and reference has undergone expert human review for accuracy and clarity. Nonetheless, some oversights may remain, and listeners are encouraged to consult the cited papers directly for comprehensive details. Complete references are provided to support independent verification and further exploration of the topics discussed. As we conclude, we invite you to engage further with the AI Frontiers community. Subscribe to our YouTube channel for ongoing insights into artificial intelligence research and innovation. Stay updated on the latest advances and research frontiers shaping the future of machine intelligence. Join a growing community of professionals and enthusiasts passionate about the evolution of AI. Your comments and questions are always welcome, helping us tailor future topics to your interests. Thank you for joining us on this in-depth exploration of computer vision. Your curiosity and engagement drive our mission to make the frontiers of AI accessible to all.